So in ASCII, decimal, hexadecimal, binary, octal are what's called a character code. So if I said to you what's a character code for the letter A, capital A, you would say to me it would be 41 in hex, you would say to me it would be 65 in denary, and you'll give me the binary, blah 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 blah. Something like that. Character code, ASCII. In Unicode, it ain't called that. In Unicode, it's actually called a code point. And if I said to you, we're using Unicode, I need you to find the code point for the capital, ooh, don't want to do that, for the capital A. Okay, for caps A. You don't need to look at decimal, you don't need to look at the binary, it's just going to be the hexadecimal. So it'll be 41. But not just that. It would also be 2 zeros before it and a U plus. So if I was to say what would be the code point for the letter capital G? You've got your G, and it'll simply be U plus 0047, and that is its code point. And a code point is simply the way in which the computer could actually understand and represent it. It's that simple. Now, in Unicode, it's only necessary to use 1 byte representation for the ASCII code. You only need 1 byte. Codes cannot be misinterpreted because the codes where more than 1 byte is needed will have restrictions. Basically, ASCII code and Unicode, there can never be a conflict. There cannot ever be a misrepresentation, ever, the way it's been set up. So what do you need to know about Unicode again? Unicode allows us to use symbols, characters from a wider range because it uses that extra zero. So the way it's been set up, it's a lot more flexible. Unicode literally is the same as ASCII code for the first 128 characters. Unicode doesn't use character code, it uses a code point. You need to be able to understand the code points. And that is the end of Unicode.